We've got it set up. You want to do your part setup, tool setup, or tool review, and then actually get into the part programming. Those three things in that order helps you with the graphics and all that. So I go to part setup. If I wasn't running a part right now, I could use the remote jog to jog around and say we're just going to have a round part and maybe put a bolt sort in it. Okay, so I'm going to pick up the center of that, and when I do, I'm just going to put numbers in there. But what you would do would be store position. Okay. So you jog over, maybe indicate a part in, and then you can say store X, store Y.
Gotcha.
In this case, I'm going to go say 20 by 20. Z-axis if you want to shift the entire program up or down. Okay. That's really all I need here. Then I go to tool setup, and I can put in a tool number, let's say tool 100. I define that tool, let's say it's an end mill, tell it diameter, say ½ inch, tool cal length. You use a tool setter to actually jog your tool down, touch off on the tool, and then go over to the top of your part and touch off on that without coinciding.
Okay.
Okay. So when you touch off on the part with that tool after it's been calibrated, that actually that would be like in your Z offset. Okay. Go back to tool. So I define my tool, give it a speed, coolant if you want, primary, secondary, or both. Give it a surface speed, say 500 surface feet per minute, maybe 5,000 tooth. And these are all values that you can change anywhere in the program as many times as you want, and all that stuff. Plus you got your overrides to
Gotcha.
adjust things. Okay. So that's that tool. So when I told it to 5 thou per tooth, it defaults to 2 flute cutter. You can put whatever flutes. If it's a 3 flute cutter, you'll see the feed rate change. So it does calculations for you. Okay. Or if you're old like me, you know how fast you want to run an end mill and aluminum. You know. So okay, so that's pretty basic. Then we go into part programming. So this part, let's say we're going to just mill a circle, finish mill it around the OD, let's say it's a 3-inch diameter. So I'm going to choose milling, circle. Tell it the center.
Wait, can you take one step back? What were the options? Milling?
I'll have to delete that. Insert block.
Okay, so blocks are called types.
Yeah.
You can do a frame, face, ellipse, 3D something.
Yeah, 3D
lines and
mold,
arcs.
which is basically 2.5D. You can take an XZ contour and like revolve it around Z.
So if you have that, do you have to import that from your solid model?
No.
How do you teach it? How do you teach it a contour?
If it's just, I mean, you program it in lines and arcs. Okay.
Oh, okay.
I've been on our lathe for the last 10 years. Okay.
Oh.
So I haven't messed with this in a long time.
Don't worry about that question.
Maybe I can figure it out. If I can remember anything. Okay. So for 3D mold, your options are draw a 2D contour, which basically is what you want to start out at. You're going to take this shape, and then I'm going to either, if it's an XY, I can revolve about X. So basically, if that's your X out, so you can do that, or you can do the nail shape. Okay. Revolve about Z, and XY revolve. Okay. And then XZ translated in Y, so you got a shape, and then I just want to say go along this.
That's cool.
It is. And
it's easy.
This we have had for oh my God, 20 years, 25 years.
Wow.
Yeah. But and people will look at it and they say, well, 3D mold, that's not really 3D, and it's not. But it's like 2.5D is what it is. It's taking a two axes and either revolving it or translating it. You know. So I'm going to draw this in 2D first. I tell it my tool number. Okay. Cut direction. Follow 2D contour or normal tube contour, and I think I can remember how that works, but we'll leave it with the contour for now. When I told it the tool number, it automatically filled in my speeds and feeds, and you can change those anytime you want. If you want to leave, excuse me, stock allowance, say if you just want to leave 5,000 stock all over, just maybe use a different tool to finish it.
Pretty easy.
The step size, how much you're going to step over for each pass. Okay? I don't know. Say, so it doesn't take too long to draw. We'll do, say, 50 cal. Tech depth in Z, how much each pass do you want to take? Okay? And then plunge feed, you know, whatever your plunge feed is. Okay, so I've done that. Now I want to define my tool. Let me think of say XC revolves about Z. So as we step down here, I should have pointed this out before, everywhere you go, you're going to get some kind of help, okay, to help you with what goes into that field, okay? If you're at a place where you're unsure, or whatever field you're in, you can always use the help button. When you use the help button, it went right to the 3D mold parameters.
That's cool.
And just, I mean, it just steps you through. And this kind of shows you what I was talking about, translating and revolving it out.
Cool.
The help menu is really nice. And it pretty much goes through everything that has to do with that 3D mold data block.
Wow.
And when I hit that, over here on the side, if you want to look at anything else that has to do with milling, you can go to one of those stick letters, how to program the circle, how to program the ellipse. So the help menu is really nice. It's really nice. So, just close that. Okay, where were we? Revolving about, okay. So I got to give it a start angle, you know, that's XB. Let's say we want to start at 0 degrees, and let's go 93. Give it a start point in Z, say 10 thou above the part. Give it the XY center line. Let's say it's say a ½ inch in X, maybe 0 in Y. The reference in X, and once again, select whether the specified axis of the 3D mold contour is relative to part 0 or the center line of rotation. Okay. I believe we typically want center line. Keep in mind, I'd probably have programmed this block in at least 15 years.
You're doing pretty good job.
But I've ran these all my life, so. But like I said, I've been on the way. Okay, so that gives us that. If we go to the graphics button, and contour. Oh, I never did. rotate. You can move that thing around. Okay. You can also hit here and go back to the default rotation. Okay. So that's basically what I've done. I've made that little.
That's cool. So can you just do a counter bore with a chamfer? Just like right here? Show us how to do that?
Sure. Let's see where that's at. Let's go over here somewhere. Okay. I'm going to, we'll cheat. I'm going to do holes.
Okay.
A drill operation. So you use drill, tap, bore ring, back stop face, all these different things you can do. Okay. Drill operations, and then you can define what it is. Okay. And you don't have to tell it any of these things. All it's going to do is it'll help in the graphics part of it. Okay. So if I just say we got a drill, where do you want the drill to start? Say 20 thou above the part. Let's go minus a half inch deep. Tell it the tool number. I'll cheat and use the same tool we had before. It tells me what my spindle speed is. Do I want to do a peck, a standard peck where it retracts to Z start each time? Or you can do a chip breaker where it just simply dwells for half a second and continues on. Okay? So if you got a deep hole, you want to do a standard peck to get the tool out of the part. Okay. Now, if I leave the peck depth at 0, it's not going to peck. It's just simply going to drill up. Give it a plunge feed. Okay. So I've defined my drill, so now I want to say my next operation. If I had a center drill, tap, I could program all of them in one data file. But we're just going to do just a drill operation. Oh, wait a minute. We're just going to do that one. So then what I do is I tell it where I want to drill that hole that I just defined.
Okay.
XY coordinates, let's say minus an inch in X and minus an inch in Y. Don't want that one, so I can just go back up. Okay.
Pops a hole in. Cool.
Now, we've got some different options for the tools as far. We've got this thing called Tool Material Library, and you basically define everything you know about that tool. You can put information in there. Maybe it's an OSG tap, 3/8/16, high spiral.
So everything in Tool 3 has to be that item. The OSG tab.
Yeah.
And then you have predefined speeds and feeds for it. It's all set up.
Yep. You can do all that. So I mean, you set all that stuff up, and then when you say Tool 3, boom, it puts all that stuff in there for you. I don't have to fill in the speeds and feeds and all that stuff.
That is really cool.
Let's see. We look at. I gotta look at the settings here in a second. It might be a little different than what I'm accustomed to. If I want to see my rapid lines, you can see where the tool rapid is.
Cool.
Okay. Or I can turn that off. Part outline. Trying to find. And now we can see the lines.
That's cool. So from here, you'd have to set your tool up, tool 100.
Yep.
Give it the tool length, teach it where Z0 is, and hit go.
What else to do? Do your part setup, do your tool setup, physically touch the part off, or not. Yeah.
So could you also probe it? Could you probe the part to see where your Z0 is?
That's what we're doing on this machine here right now. We're using probing. The way those parts are, there's two parts in the tombstone. So the bottom part is a rough stop. The top part is the first operation. It's going to be used for the second operation. So the first stop, the probe comes in, probes one side, probes the other side, probes bottom, probes top. Says, okay, X, Y, 0 is going to be the center. We can tell it to just probe an edge or a corner and make that 0. So you make 0 wherever you want it. Okay? So this thing probes that part, does all the cutting on it, then on top is the second operation. So then the probe comes out again, and it probes a hole that we're calling 0 on that, or actually it probes all 4 holes because we're furnishing it, and that gives me a work offset for each individual hole.
Okay.
Gave me a different work offset for down here, another one for these holes. I mean, it's...
So does it then generate G code that runs everything? Like once you do this conversationally,
It's conversational.
So you never see G code. There isn't G code in the background. It just does it because it does it.
I wouldn't say there's not G code in the background, but it's not G code that you would run on a machine.
All right. So
It's not industry standard.
if we make our first article in a hole that we're interpolating as undersized, we want to bump it out a little bit. What's the process for that?
Okay. Let me go ahead and program this hole here. Now I'll just maybe
Is there
counterbore or something.
Yeah.
Okay. So we drilled it with that 1/2 inch. I'll do a review of the holes from here. The next block, I'm going to do some milling. I want to mill a circle. XY center, did I say?
It's -1, -1.
-1 and -1?
Oh, I'm glad you remember.
Right, I mean, I am too. Okay, so that was a 1/2 inch end mill. So let's make this like a 3/4 radius. Back finger. Okay. Z start, Z bottom, Z minus 0.2. Start angle. The start angle, when we do a mill circle from the center, where do we want to start at? We default have 0 degrees as 3 o'clock.
Oh, okay.
So if you're plunging into a part that already has a hole over here and you want to plunge over there, you can give it exactly that location to plunge in.
So you're plunging into nothing.
Right. Okay. So you can leave that at 0. We're going to use that same tool we had before and go say 25. There's the circle in this middle. Obviously I went way too big for the counterboard, because you can see the blue there, it didn't remove the stop. And that's the other nice thing about...
Because we made it a circle, not a pocket?
Right, right. And that's
okay.
What I was going to get to, though, is how easy it is to go in and say, oh, I forgot, I wanted to make this. Oh, I never did tell it. I told it online, so that's what it did. My options are I could do a simple inside, outside, inside tangent, where it plunges tangent to the wall, okay? Because typically it's going to plunge at an offset. Or you can do pocket boundary. And you can do the adaptive hat, zigzag, and there's lots of things you can do.
That's cool.
Okay, so all my information's there now.
Cool.
Yeah.
That's really cool. So and then if we wanted to change the size of it, we could either use a tool comp or just change the physical or the digital dimension of our pocket.
Yeah, you could go into the program itself and change that start point or change that radius. Let's say we only wanted to make it 6.5. So So now it's going to go smaller. It always auto scales. That really wasn't.
Can you simulate the material removal on this screen? Like have its little tool cut stuff away? Just so you can visualize it?
I'm going to take the speed down. Hopefully it will. There it goes.
Oh, cool. Yeah.
Let's see what it did.
Does it give you an estimate for how long it took?
In the part, when you go to run the program, we've got a compute estimated runtime.
Oh, okay.
And we do a check for errors to see if you've exceeded any travel limits or spindle speed max or something like that.
This is cool.
That'd be handy.
This would be really cool.
And the compute estimated runtime is pretty darn accurate. It takes into consideration tool changes and everything.
Movement.
Yeah.
This is super cool. Thank you for showing us this.
Yeah, not a problem.
Okay, I'm just going to open this other screen here. I'm going to import step file. That's then brought in this model here. I'm going to select this face. I'm going to create a block. And then it tells me please click on the top of the feature for the Z-star. Then press please select the right frontal direction. And then it's just imported pocket and a pocket island automatically.
Gotcha.
Straight off of that, it knows it's material. So the Z-star's picked up on the top surface, the bottom depth from there to there. What I need to do is put in a tool, press the draw key, let's just turn off. That tool is too big to go down the side wall, so I'm just going to use a smaller tool.
So how come is this extra material that...
That's automatically created stock geometry.
Oh, okay.
Stock geometry, yeah. Okay. If I just bring the solid model back, so we're back to there again. Okay.
So okay, I think I see it.
So what I'm going to do now is select this feature here at the bottom, create a block, click on the top feature, this one, click the side contour.
We were supposed to call Kenton.
That now has just put that block in here. Okay. It's picked up the depth, all the contour. So now if I just use the tool number 1. Turn back on the simulation.
That was pretty hard.
Now as well with this pocket here, I don't know if you call it over here dynamic milling. No?
No.
That's an old-fashioned toolpath used for Z-level cutting strategy. If I change it now to this dynamic milling, I will now get this toolpath.
Oh, cool.
You also get the option now to do what we call rest machining. So I can select a smaller tool. Okay. This will now look at that pocket and only machine in the areas what the first tool couldn't get into. So this little area here.
Oh, it won't machine in that area.
This tool here was too big. So this now gets in the areas that tool couldn't get into.
Dang. This is pretty easy.
And that's all come off of that model.
This is pretty easy.
That was just a step file that you imported.
Step file straight in, that's just 3 axis. If you had a 5-axis profile with pocketing on here, same thing, select the pocket, it will automatically put in all the relevant transform plane blocks so it knows where to move it to. It's the same on all the 5-axis machines.
Wow. So then you'd have to set up your tools ideally should all be loaded in the machine for all this stuff.
In there. Yep.
But you'd have to set up where your part is on your table.
Yep.
And
Yeah, 3 of them on there.
Three of them on there. All you do then, program it like we've just done there. All we need to do is put one block in front of the program, tell it the X, Y, Z position to each of them and a rotation angle. It's easier than a G54.1. Let's show you. Right. So I'm just going to make this bit up now. Right. So graphics only. So this here, that was my shape originally.
Right.
Okay. Just going to add one block in here. What we call a transform plane group. Transform plane group locations. This is a shift. So from this point, I'm going to shift one here, one there. Okay. So the first one is just move it 4 inches minus 2 inches. Okay. And I'll rotate around the X. Let's go. So I'm going to rotate that back 30 degrees that way. Okay. The next one we'll have over here somewhere. X. Let's just go 3 inch. X minus 3 inch minus 2 inch. That one is going to come 30 degrees towards me, around that way. Let's go around Z 60. And then the third one in this corner, minus 3, minus 3, minus 2. This one will come that way, 30, and around that way. Let's go. So I've just put 3 separate positions in there. Need to close it with transform plane group end. Just draw key now. Hoping one there, one here, one there.
well, that's cool. That is really cool.